we just introduced the concept of inadmissibility, and I'd like to give you a fun little exercise on inadmissibility. This is a neat little, sort of surprising little exercise. Let x1 to xn be normally distributed with mean mu and variance sigma squared. And we're going to consider estimating sigma squared, and we'll assume mu is known. Let's take the loss function to be the square loss. So L of, in this case, theta is sigma squared. So L of sigma squared 1, maybe I'll just write it this way. Sigma squared 1, sigma squared 2 is just the square of the difference. Just the square loss. And remember, we defined, so recall, that we defined the estimators, the sample mean, or not sample mean, the sample variance and the sample, the unbiased sample variance and the biased sample variance. This one is the biased sample variance, and it's xi minus the sample mean squared, 1 over n, times the sum of xi minus the sample mean squared, and that was the biased one, and the other one was 1 over n minus 1. Or actually, we could write n times, so this will be suggestive. S squared is n times this one divided by n minus 1. More generally, this might suggest to you, we could define, let's call it SC squared to be sigma hat squared times c for some constant c. So c is some, let's say, positive real number, or non-negative at least. And now think about the following questions. So 1. So let's say first, does sigma hat squared dominate S squared, or vice versa? Does S squared dominate sigma hat squared? You know, it'd be interesting to know that, because then you might want to use one rather than the other. Are sigma hat squared and S squared admissible? Admissible. And 3, thinking about this guy, as c ranges over non-negative numbers, is there a best, I'll put that in quotes, something you can sort of, when you work it out, I think you'll see what I mean by this. Is there a best SC squared for some c? In other words, is there some choice of c that gives you a best SC squared? And so if you can find that, does it coincide with one of these? So if you work out these, I would encourage you to work these out, and I think you may be surprised by the answer. And let me point out one thing to remember in all this is that this all depends on this squared loss function here. And so if you decided that this was an inappropriate loss function for comparing variances, which some people do, then you might not want to put too much stock in the result. But if you do like the squared loss for variances, then these results are perfectly fine. So this would also give you some practice if you, since the square loss corresponds to mean squared error, and we have a formula for mean squared error, then that would give you some practice with that formula also. All right, so I hope you have fun working out this exercise, and I'll leave it there. Okay, have fun.